All right, good morning, everybody. So today we're going to factor a little bit more, and we're going to factor with the imaginary um, into the imaginary factors. So one thing to keep in mind is if you have a complex number that's a solution, then that means its conjugate is also a solution. So what that means is, let's say you know that 3i is a solution. If 3i is a solution, then that would mean that negative 3i is also a solution. If negative 6i is a solution, then positive 6i is a solution. If 2 plus 3i is a solution, then 2 minus 3i is a solution. And then this basically says that if they are real solutions, you could just look to see where they cross the x-axis. Those would be called x-intercepts. But if the solutions are complex, you can't see where they cross the x-axis. And so what I want to start with before we get into today's lesson is a little review. And this is from a couple units ago. How do you multiply x plus I times x minus I? And so this should be review. You would take your x times your x. And I am going to go through this part a little faster because we spent time on this already and it's supposed to be just review. I would then take x times negative I excuse me, and then I would take I times x, and then I times negative I. And see, I times negative I would be negative I squared. So if you take x plus I times x minus I, which we call those conjugates, so if x plus I is a solution, or I should say if negative I is a solution, then positive I is a solution. Notice these two middle terms cancel. And you should remember that I squared is negative 1. So if I squared is negative 1, and I brought down my minus, the two minuses would make a plus, and I'd get x squared plus 1. So what that means is if you needed to factor x squared plus 1, it would be x plus I, x minus I. The next one, if I were to distribute this, and again, it's just review real fast, I would take x times x. I would take x times negative 5i. And then I would take 5i times x. And then 5i times negative 5i would be negative 25i squared. Now notice, because these are conjugates, the middle terms will always cancel. So this and this will cancel because they are additive inverses. So then I'd get x squared. And then here, I squared is negative 1. So that would be negative 25 times negative 1 would be plus 25. So if you were to factor x squared plus 25, which would mean going backwards, it would be x plus 5i, x minus 5i. And we talked about how if this is a minus, like if this was x squared minus 25, this would be x plus 5, x minus 5 without the I. But as soon as you put that plus there, you need the i's. Here's an example, and again, this is review. If I have x squared plus 9, I would take x squared, and I would recognize that x squared is x and x. And I would recognize that 9 is 3 times 3. And then I would do x with the 3, 1 plus, 1 minus. And then you look, if this is a minus, we're done. They're real factors. If this is a plus, you need the I there. So I would need an I here and an I here. And again, this is review. We covered this last semester. X squared plus 5. I would take the x squared and make that x and x. Now, 9 was easy. 9 was a perfect square. It's 3 times 3. You try to break it into the same number twice. But 5 is not a perfect square. It's a rectangle. The only thing you can do is 5 times 1. So the trick there, anytime you can't use a square, is you just use the square root, because square root of 5 times square root of 5 is 5. So I'm going to put plus square root of 5 minus square root of 5. And because it's a plus, I am going to insert an I. That shows that those solutions are not real. They're going to produce too complex solutions. All right, so that's review so far. I felt that that was important to do. Now let's go into the new stuff. And all of these say, find the solution. We're not going to find the solution yet. So what we're going to actually do is we're just going to factor. Okay, so we're just going to factor. We're not going to find the solutions just yet. So that you can see there's a few examples I hope to get through. At the very least, these 4. So we are not finding the solutions. All we're doing is factoring. So let's start with the first one. We also talked last semester that if you have a quartic, so that means to the 4th power, and there's only 3 terms, and it follows the pattern of a quadratic. So if it goes 4 to constant, then you can factor it just like a quadratic. And so I know it's been a while, but you would make a little x here, and you'd put this number on top. And then you'd put the -3 on bottom. And then you're looking for 2 numbers that multiply to -4, but add to -3. That would be -4 and 1. -4 times 1 is -4. -4 plus 1 is -3. And then from there, normally you would put x minus 4, x plus 1. Since ours is a quartic, we're gonna break that into x squared. So it's gonna be x squared minus 4, x squared plus 1. And then from there, we're trying to factor these into linear factors. And so x squared minus 4 is difference of 2 squares, x and x, 2 and 2. and we don't need the I because it has a minus. X squared plus 1 is also 2 squares, x and x, and then 1 times 1 is 1. And because of the plus, you would need to put in an I. So you'd put x plus 1i, x minus 1i. And we're going to stop there for factoring. But if someone said, what are the solutions? You would say, the real solutions are -2 and 2. And the complex solutions are -1i, +1i. And notice, complex solutions, the conjugate will always be a solution too. So if -1i is a solution, +1i will also be a solution. All right, number 4, same thing. You would put -36 on top. You put the -5 on bottom. And we're going to factor this just like the quadratic because it is 4 to constant. 4th power, 2nd power, number by itself. So then I have to think what multiplies to -36, excuse me, but adds to -5. And sometimes they don't come directly to me. 12, 3, 4, 4 times what? 9. 4 times 9 is 36. Oh, there we go. If I did 4, oh, someone told me. Yeah, 9 times -4. Good job. Let's see. So 4 and -9, or -9 and 4, same thing. So from here, I would go, because it's a quartic, I would go x squared plus 4, x squared minus 9. Plus 4. And I'll write this one in a different color this time. The other one would be x squared minus 9. Now x squared plus 4, you have x and x, 2 and 2, and because of the plus, you're going to have an I. So it'd be x plus 2i, x minus 2i. And then x squared minus 9 is x and x, and then 3 and 3. And because it's a minus, we don't need the I, so it's going to be x plus 3, x minus 3. So if someone were to ask me for the solutions, I would say -3 and 3, and -2i and +2i. And notice that if the solution is imaginary, the conjugate will also be a solution. All right, so not too bad so far. Number 5 is a little different. And the reason why number 5 is a little different is because it has a leading coefficient. Notice this has 2, a leading coefficient. This was a 1, 1x to the 4th. This was a 1. So anytime it has a leading coefficient, you still factor it like a quadratic if it's 4 to constant. However, and I know some of you may not remember this, but you're going to take 2 times 40, and then you do the slide divide trick that I showed you. And you only have to do the slide divide if there is a coefficient besides 1. So let's do that together. So because there is a number out front, I would take 2 times my 40, and I get 80. That goes on top. Now we didn't do that on the other ones because it was a 1. I then put the negative 24 on the bottom like I did before. Oh, to multiply the positive but add the negative, they're going to both be negative. And if someone wants to tell me what that combination would be, if you could figure it out before me, it'd be nice. You could chat it in the box. Let's see, 80 divided by, well, that'd be 2 and 40. 4 and 20, 4 times 20. Oh, there it is, 4 and 20. So if I take 4 times 20, I get 80. If I take 4 plus 20, I get positive 24. So to fix that, I'll just change those both to negative, because negative times negative is positive, negative plus negative is negative. Okay. Now from there, normally I would put x squared minus 4, x squared minus 20, but because we have that leading term, we have an extra step. And I'll remind you of the extra step, okay? And actually, so we would do x squared minus 4. And I would do x squared minus 20. However, and I know it's been a while since I've covered this, you divide by this 2 right here. So you divide both of these by 2. And if it reduces, you reduce, like 4 divided by 2 is 2. 20 divided by 2 is 10. And you know what I just realized? And this is very important. Anytime they both reduce, that means the slide divide won't work. So it's a trick. And the reason why it won't work is because there was a GCF to begin with. So let's take a step back, and I'm kind of glad I did this, because if this reduces and this reduces, then nothing will move to the front. And if nothing moves to the front, it won't ever multiply to 2. And so I talked about this when I covered this. If there's a GCF, this trick does not work. So let's try again. So I'm going to write down the problem again. And this time, I'm going to recognize that the GCF is 2. So I'm going to take out the 2. Basically, I'm just dividing everything by 2 and putting it on the side. And now this problem becomes just like the other ones. So I would make my x. I need numbers that multiply to 20 but add to negative 12. That'd be what, negative 2 and negative 10. And so then I'd have 2. X squared minus 2, x squared minus 10. Okay. And then from there, we could break this into x and x. 2 is a rectangle, so we can't break that into what would you call that? Rational number. We would just break that into square root of 2 times square root of 2. So I'd say 2 x plus square root of 2 x minus square root of 2, because square root of 2 times square root of 2 is 2. And notice, because it's a minus, we don't need the I, so they're real factors. And then here with the 10, again, 10's a rectangle, so we could just do square root of 10 again. So we could do x plus square root of 10. All right, ran out of room. It's minus square root of 10. And so this one has 4 solutions. Negative square root of 2, positive square root of 2, negative square root of 10, positive square root of 10. And remember, if it's to the 4th power, it should have 4 solutions. It could all be real, like this one, or they could be half imaginary, half real, or in some cases, they're all imaginary. All right, number 6 looks different. And the reason why number 6 looks different is because there's no middle term. So what this means, because there's only 2 terms, I'm going to factor by difference of 2 squares. So I could break this into x squared and x squared. I could break that into 8 times 8. So I'd say x squared plus 8. X squared minus 8. And then from there, x squared plus 8, since 8 is actually a rectangle, or if you break it up, it'd be a rectangle. So I'm going to use square root of 8, square root of 8. So that's really, if it doesn't make a nice square, you just use square root, because square root of 8 times square root of 8 is 8. And then because of this plus, I need my I here. And some people put the I in front to make sure it's not underneath the radical. And then for this, you get also x plus 8, x minus 8 with the square root. But because it's a minus, you do not need the i's. And that's it. Okay. I don't think I'm going to completely go into number 7, but I'll kind of show you real fast how you would go about it. It just says, so here are the solutions, and they want us to go backwards. So they want us to write the fact and then distribute. And so what they're trying to get you to understand that is, if the 0 is negative 2, then the factor would be x plus 2. And if the 0 is 3, the factor would be x minus 3. If the solution is negative 4i, the factor would be x plus 4i. And then, because, and this was the first thing we talked about, if a complex number is a solution, so if you have a solution that's complex, then its conjugate is also a solution. So even though they didn't tell us, we know that if negative 4i is the solution, so is 4i, which would then make the factor x minus 4i. You would then multiply all that out, which we're not going to do. That would take way longer than the time I have. Okay. And then that would produce x to the 4 plus something, something, something. That's not in your practice, but I did want to show you how you would do those in case you ever saw those anywhere. But you would just take x plus 2 times x minus 3. You would take x plus 4i times x minus 4i, and then you would simplify that. Here, if the solution is negative 1, the factor would be x plus 1. If the solution is 3i, then the factor would be x minus 3i. And if 3i is a solution, so is its conjugate. So negative 3i is also a solution. So that'd be x plus 3i. And then you would multiply all that out to get the original polynomial, which again, we're not going to do. Okay, so that brings me to the practice. Notice it says factor, we're not solving. And remember, before you start factoring, you need to move everything to one side. So you would do 4, and actually these are like terms. But you need to move like the 6 over. You need to move the minus 10x squared over. So for like this one, it would be x4, x to the 4th, minus 10x squared, plus 2x squared. Oh, that's a 3. Oops. So that'd be x to the 4th plus 2x squared, or 2x cubed, minus 10x squared. So just make sure you move everything to one side first before you factor. And notice this one is not 4, 2 constant. It is 4, 3, 2. And the reason why is because it has a GCF in there. And we talked about that last semester. So you would need to take out, it looks like an x squared. Okay. So the ones that look just like what I just covered would be anything that's 4, 2 constant. Which, so like number 2 would be 4, 2 constant. Not really sure why I didn't put very many examples like what we just did, but there we go. So this is a variety of factoring review, but other than that, that's all I have. Just try to do those 12 problems. Good luck. And you can sign on at office hours if you have any more questions or you want any of these worked out. But I'm going to sign off. Nice seeing you all.